Alright, so July 13th today, working on improving the behavior tree for the monsters here. So far what I've done is kind of scrapped this section here. This is the old moving to the player and just attacking. Instead I have this. It's more condensed now, running in parallel, so this allows the monster to actually move and attack the player, which I think is a nice thing. Compared to it moving, it reaches the player, then it stops and attacks the player, which gives the player a huge gap to run away. It just makes it way too easy. I'll keep this here just in case I need to go back to it, but I really like how it is right now. You can see they're both running in parallel, and he's attacking while he's running. And then he can hit you. So I think that'll be really good. In terms of what changed, I'll run through it very quickly, ignore all of the errors. So now I'm keeping track of state if they're already attacking, and then we can just return early, as well as firing a delegate once the attack montage has ended. Here's how it looks down here. Pretty straightforward. Now, attack player, just doing any sort of necessary casts. We're checking if we're within the distance of the player. I'm not using the acceptance radius within the move to task, because I found out if I was using this acceptance radius, then it wouldn't allow the player to move again. I'll show you here. So it's 250. They just stop, right? I know it's larger than the acceptance radius within the code, but when they're frozen right here, they should be attacking and they won't be moving. So that's why acceptance radius here is set to 0, and now it's being controlled within this task here. So we're checking if it's within the radius. If it's not, we're returning early if it is. If we're attacking, again, we return early. We don't want to repeat attacks. Or we're setting up the delegate here, starting the attack player logic, returning in progress, and then once we get the broadcasts back to us, then we'll say it's succeeded, and then we can attack again. So I really like how it is right now. It's a lot better than before. I think allowing the monster to be able to attack while moving just makes the gameplay smoother and a bit more complex and a bit more difficult. Now all of the animations are fine, I'm pretty sure. If there's one thing I need to change, it's the fast monster, this animation, because it uses its foot, and actually, yeah, it looks a little bit off, especially with its left leg just standing there and moving, just sliding around. So maybe I'll change the animation for that. But all the other animations should be good. So yeah, making progress, happy with this, and yeah, talk to you later. Okay, so a few hours later, still adding on to the behavior tree here, and now I've split it up into two states here. So we have the arena behavior and the hub behavior. So if the player is in the arena, they'll move and chase the player and attack them. If they're not, they're just gonna stand there and do nothing. How this is all set up, I went ahead and created some trigger volume boxes. I actually made a blueprint for them. So what we're doing on the overlap, we're checking if it's the player, we're getting the game state, and we're setting that they're in the arena. And yes, I did make a custom game state class, so we're just storing the arena. If they're in the arena, we have a delegate set up and just a setter or getter. Setter, super simple. We're just changing the bool and broadcasting it. So that's how this is set up. Don't need this anymore. So the only thing that's left within here is actually teleporting the player from the hub to the arena, which I'm sure it'll just be one node, just move player 2 or something like that, but I'll see. And then within the monster AI class, we have the function here that's set up to be listening to that player zone change, and all we're doing is just updating the blackboard here. Also at the very beginning, when we're starting the behavior tree, we're just getting currently in the arena, which will always be false by default. The player is going to be starting off in the hub, but we're just setting that here, and then just made the blackboard key, and it had a decorator around the arena behavior. So when they're in the arena, this, not, we'll go here. Let's check it out. So this is false. We see the zombie over there. Just, here he is, doing nothing, which is perfect. We have the trigger bounce set in the corner here. Walk into it. There we go. Starts chasing us. Run into it again. I don't think I ran into it. This pop-up is blocking my screen. Run into it. Boom. False. Now he's just gonna stand there and do nothing. So that's great. I'm getting closer and closer to making this system better. I think the next thing I want to do is get that teleportation functionality down. Just teleporting from one place to another. And then after that, I think I'll call it for the day. I got a couple of things done today, so I'm happy about that. So July 20th today. A small delay between now and when I last made a recording. I was on vacation from work and I didn't really go too hard into working on this project. I did do some work, but not a whole crazy lot. Really just enjoying my vacation time. Saw the Odyssey yesterday. That was pretty good. Anyways, more monster work was done over the past week. Mainly I was learning more about EQS, what I could do with the monster systems within this game. And then I also added a blood hit effect into the game to add a little bit more feedback. So when you're hitting the monsters, just get that little extra feedback. Because I don't think I'm going to do hit markers, sound effects, or even the visual indicators. So I think just adding blood effects will be good. So how this was put together, I found a blood texture online for free that I can use. Created a material out of it. We're just using the sample, turning it translucent, and then adjusting the opacity and the base color based on a particle color. What I should probably do too is create a material instance. I don't know why I didn't do that before. But there's a material instance. From there I created a Niagara system effect. This was based on the omnidirectional burst. Added in the material blood, which I'll change to the instance, and then just adjusted some settings from here. Dialed that up from 1 to 65. Adjusted the lifetime to be way smaller so it's faster. So it's 0.6. What I did is just set it to 0.6 and 1. So I like it like this. And then the size going from 5 to 10 to 20 to 25. So now it does look like a hit effect. So that's one small thing I got done, besides from behavior tree and AI changes. Going on to the actual AI work, I had this new tree set up, so it's split between arena and hub behavior. Here's my attempt with EQS. So hub behavior still remains the same, nothing changes there. However, once we get to the arena behavior, that's where I wanted to implement EQS and have it be a little bit more interesting. So the whole goal with EQS is that I wanted to avoid monsters running in one horde. So instead of monsters just running in one horde directly at the player at all times, what I was hoping would happen is these monsters would use the environment as well as the distance between the player and the other zombies to be able to flank the player. So they all wouldn't just follow one path. They would choose different directions and then converge in onto the player to make it a little bit more interesting and difficult. So that was the concept I had in mind. I went through Unreal Engine's documentation on how to get EQS all set up. I learned about creating a generator as well as different tests for the player. So this is just checking if a path exists, checking the distance to the player context, which again, EQS context is something I learned about, but it was pretty straightforward to get all set up, as well as the distance between other monsters. Path exists, we are filtering and scoring because we only want to test paths that are actually valid. We don't care about paths that won't work. So we can filter those out, and then distance too, we're just going to score those. There was also this little EQS testing pond, which I didn't know there was a class for that, but it was super nice. Because with the testing pond, I can really visualize how EQS works in the world, and also adjust the parameters here. So I can really visualize it and understand it how it would work. We have the context, which again, straightforward, at least for what I needed. Player context, I'm just getting the player. Other monsters, we're just getting the pool, getting all of the active monsters, and that's what we're removing. We're also removing itself because we don't want the context to query against itself. We only want this monster to refer to all of the other monsters, right? So that's why there's this remove here after the cast. So yeah, with all that set up, we got the generators, some tests, context, then it's all hooked up to the behavior tree now. So the EQS is running periodically, just based on an interval here. And then in here, there's two paths it can take. The far approach, when the monsters are far away from the player, they're going to use an approach point, which would be an EQS node, one of the EQS spheres, and the monster would go into that player and use the approach point while they're far away from the player. Once they get close enough to the player, then the monster would go into this branch and hone in on the player. They wouldn't move to the approach point, they would just move towards the player, then attack them. So that was kind of the goal I was looking for. Use approach point when they're far away to kind of maneuver and flank the player. Once they're close enough, they would hone in and attack the player. However, maybe this is just my understanding. I'm sure something I'm doing is wrong, because they wouldn't close in on the player. I think just because of how I'm doing something with the EQS, they would just run to a random location that becomes old and just run randomly. But when they get close enough to the player, then they'll just close in and have the same behavior as before. Nothing too new. So I tried debugging around it, seeing what I can do, changing some of the parameters, but nothing really ended up fixing it. And eventually the end goal would just be them closing in on the player, just honing in, and it would still have this horde-like behavior, which again, I'm perfectly okay with. So I ended up just scrapping this because it ends up just going back to the core behavior of what I wanted. It was just a little extra functionality that didn't work as intended. And yes, I can spend more time trying to debug it and trying to fix this issue, but there was also this RVO avoidance in the character movement component that I can use, which isn't directly flanking, but with how I want the map design to be with spawn points. Let's say this little area here is the playable map that the player can play in, and then all around the outside is spawn points. That's what I have planned. With that avoidance setting checked off and spawn points working all around the map, I should get the behavior I'm expecting with being able to flank the player. Also, I do think how it's a little goofy how they kind of just move around like that, but that's okay. But I think with those two settings and how the map design will be, I'll be able to still get the flanking behavior I'm looking for. Because let's say I'm over here behind this wall. You got over here and then they're coming over here, so I think, yeah, I think it'll work fine with the RVO avoidance and spawn point placements. Was EQS a failed attempt? Yes. Was it wasted time? Absolutely not. Because now, if I decide to use it in the future, I know how to get it set up. I know what to kind of look out for. I know how to get generators up and running. I know which ones to choose. I know how to get context set up. I know about tests, what different tests can do. I just gotta learn from my mistakes and make it better. I don't know if I'll be using it in this project, maybe in a different project, but yeah. So that's how the monster system will be. I don't think there's too much work I need to do now that's left for the monster system. I mean, all the other monster types are added. I got the behavior down to where there's constant tracking. There's the zone differences as well as moving and attacking. So I'm super happy with that. There's a little bit more feedback with the blood hit effect. The only thing I think is left for this monster system is just adding more sound effects or when the monsters hit the player and on death. So I think really that's all that's left. I'll get around to that eventually because that's not super important, and I think I have some friends that want to do some of the sound effects, so I'll get some of their sound effects imported into the game too. But yeah, next up would be the resource system. Start working on that again. Same thing similar to the monster system, turning it into a subsystem instead of an actor, and just going from there. Another day, some more work done, and yeah, catch you all later.